Well, welcome everyone. We'll get started here in probably about 2 or 3 minutes. We wanted to admit the folks in the waiting room a little bit early so you all can get settled. Hope you all are doing well. Beautiful weather here on a nice Friday morning. Also, I'll repeat this throughout the webinar, but please, if you could put your name and your association in the chat, that just helps us keep track of the attendance a little bit better. So if y'all could do that, I'd appreciate that. And we'll get started here in just a few minutes. I think I'll wait just a little bit longer, maybe 30 or seconds to a minute. If y'all want to time me, you can. Just again, I think we're expecting a little bit more folks than we have right now. So again, I'll just wait one more minute and then we'll get started. All right, I think we can get started. So welcome everyone. My name is Chris Smelson. I am the program manager of the Louisiana LTAP, the Local Technical Assistance Program. And on behalf of LPESA, which is the Louisiana, excuse me, Parish Engineers and Supervisors Association, we welcome you to another virtual showcase. I'll talk a little bit more about the showcase and some housekeeping items here in a second, but our featured presentation will be by Mr. Wilfred Berry from SJB Group, and he'll present for about 40 minutes or so, and then we'll have a Q&A session at the end. But with that, I'm going to go ahead and do a few housekeeping items. I think you all are pros at Zoom and this virtual environment that we're in. In fact, the presentation is about the meta universe a little bit. So again, just please be sure to mute your audio and also your video unless you have a question, or of course, if you're otherwise presenting. Also, feel free to put any questions in the chat. As I mentioned, we'll have a dedicated Q&A session at the end of the presentation, and we'll be sure to get all those questions answered. Again, please take advantage of the presentation and the presenter and the experience that he has. So I really do encourage everyone to, if you have a question, don't hesitate to put it in the chat. Excuse me. And then also, I would ask everyone that's, again, who hasn't done so already, if you could put your name and affiliation in the chat, that just helps us track who's attended. A little bit about LTAP. Again, this is LPESA virtual showcase, but it is being facilitated by LTAP. So again, LTAP's the Local Technical Assistance Program. There's one in every state, and there's also one in Puerto Rico. And currently there's a tribal center, but they're going to actually divide those and make those into regional tribal centers. But we are a unique partnership between LSU, all the LTAP staff or LSU employees, between DOTD. A majority of our funding comes from the DOTD and of course FHWA. LTAP is an FHWA program. So we provide training and, as the name suggests, technical assistance to local agencies. We have a standard, we call it the Rhodes Scholar program. We have a standard set of courses that we offer each year, rotating basis. And we also have some on-demand classes. Either way, again, we're here to help the locals. So if you do have any questions or you think we can assist in any way, don't hesitate to contact any of us. and a little bit about, again, the virtual showcase. So these actually started, I think, December of 2020, mainly through last year, and we had them monthly. And again, the purpose is for the associate members, again, just another venue for them to interact with LPSA members. Also for the members of LPSA to learn more about a specific topic, and of course the services that the associate members do provide. That was important, of course. It's still important, but at that time when we started it, it was right in the middle of COVID. So it was an option. We wanted to provide at least some kind of option, again, for this interaction. Now we have the LPSA conferences that we've hosted in person a couple times already. So we decided to make these quarterly instead of monthly. So this is actually the first one that we're doing quarterly. Again, I think it's still great an opportunity, again, for the purpose of associate members interacting with the members. And so, and it's free. And also we offer one PDH at the end, and we'll email those out likely in the middle or late of next week. Again, I'll just repeat myself. If you haven't done so already, if you could put your name in the chat and your affiliation, again, that helps us keep track of who actually attended and helps us deliver those PDHs a little bit easier. So with that, I'm going to turn it over to Ms. Dina Capone. She actually really the one that organized all this. She does a great job organizing and facilitating the LPSA conferences as well. But I'll turn it over to Ms. Dina Capone to introduce our speaker.
Good morning. Thank you, Chris. Very kind of you to say that. Appreciate everybody's time joining us on a Friday morning. Today's speaker is Mr. Wilfred Barry, who serves as the Secretary of SJB Group, which is a multi-division firm that specializes in land development, construction management, and surveying and planning. Mr. Barry has more than 44 years of extensive civil engineering and planning experience related to public utility systems, streets and highways, land use, and site development. He has extensive knowledge in the areas of utility and pipeline design, installation, transportation projects, and land development. He has served as principal in charge for all of SJB Group's scanning and modeling services, as well as surveying projects, including state and municipal projects for commercial and residential ones. He has also managed numerous utility relocation projects and topographic surveys. In today's showcase, Mr. Barry will present what reality capture can do for engineering and architectural projects. So, Mr. Barry, it's all yours, sir.
Good afternoon, morning, excuse me. All right, I had to find the unmute button. So my presentation is going to be about reality capture, and with a little twist at the end, it's the gateway to the meta universe. So here we see a series of pictures that shows different people capturing scans, video imagery, various environments, buildings inside. Outside, you have drones, you have spaces above the suspended ceiling, automation for manufacturing, and more. And you have a scanner at the bottom right. So this is all part of the business of today as we go at the speed of light towards tomorrow. It's quite challenging to get it all done. So I'm a partner in SJB Group. We made an investment in LIDAR scanning and videography in 2016. We keep investing in that to the point where today we have 4 scanners, 2 drones. We have several types of mounts that go on trucks, ATVs, handheld device, airboat for both the LIDAR and the video. So reality capture tools and applications. Well, the tools include high definition 3D terrestrial laser scanners on tripods. There are multi-stations that are essentially enhanced total stations that have scanning capabilities. There's mobile LIDAR, which could go on the ground, on vehicles, or through the air, drones and helicopter. And then there's UAV, the whole drone market is huge. SLAM technology, which is an emerging market. And then all of these tools are used in transportation, volume calculations, grabbing the detail of surfaces for building facades and piles of gravel, whatever it may be, as-built locations, tracking progress of construction projects, and then mechanical, electrical, plumbing, mapping, which has a lot of use in interior spaces for buildings and refinery petrochemical units. So new technology has always been a situation where some embrace it, some push back, and I love this cartoon. So the inventor of the wheel encounters his opposition with no wheels here, no new technology, or just a plain old no. So anyway, those were the early days. But today we have LIDAR. What does LIDAR stand for? It stands for light detection and ranging. A LIDAR scanner uses lasers to measure the distance of objects from the scanner based on the amount of time it takes for the laser light to reflect back to the scanner. And on the right side, you have a typical laser scanner. You have the laser source, which is here, and it emits many, many light beams against a mirror, which gets reflected to the outside, and then gets reflected off the object back to the mirror and to the receiver, which is a sensor. And that time of transmission and return calculates the distance away from the scanner. And of course, this cylinder contains it all, and it scans at numerous times per second, and the laser fires off at hundreds of thousands of times a second. And so now you have a device that is capturing an enormous amount of data. So the terrestrial LIDAR scanners, which are essentially static, fixed on tripods, they're highly accurate. The cameras on board, these scanners colorize the point clouds as part of the processing. The accuracy of the scanners are incredible now, and it helps these modeling efforts of whatever it observes. The detail is very good for architectural and the mechanical, electrical, plumbing renovations that we see going on all around us. The scanning total station is a highly accurate total station that has LIDAR capabilities along with a camera that takes pictures of the window that the unit is scanning. Most of these units are very accurate, 1 second or greater. It has an enormous range, often more than the normal total station, so that it can see far off distances. And from that, you can have the image that will colorize the data. Here is an example of a multi-scanner that's shooting a dam face, which is one of the common applications. Mobile LIDAR and GPS is getting more and more accessible. There's many manufacturers today. These units go on vehicles and through the air. This particular one is one we own. We bought this from LIDAR USA. It was an integrator of technology and software. The unit on the right of the box is a Velodyne unit, and this scanner has 32 lasers, and it's a laser scanner that is very common in autonomous driving. You see these scanners fixed on the four corners of the top of the cab of a vehicle. And then the box itself has an inertial measurement unit and a navigation system so that it can track itself with respect to a satellite constellation above in the sky. So the LIDAR scanner is collecting 3D observations, and the panorama unit above is called a ladybug camera. It has 6 sensors, photographic sensors, 5 in the horizontal, 1 vertical, that subsequently creates a bubble image that is used to colorize the laser point clouds collected by that scanner. So it's very common. We're doing all this X, Y, and Z state plane coordinates. And with control, the quality of these observations get down to 500s or less for surfaces. So it's worked pretty well. So UAVs, fancy name for drones, unmanned aerial vehicles. These are very common, except the LIDAR, they're very affordable. Once you add LIDAR to the drone, you've priced it out of the typical amateur and into the survey grade market. So UAVs, they can access remote terrain. The LIDAR can penetrate tree canopy. Drones allow us to see over buildings, treetops, and it's relatively quick. The types of drones you're seeing here, there's two broad types. One is fixed wing, and you see the sense fly there. And then the other ones are copters, and you see the Matrice 600 and a Velodyne LiDAR scanner. That's our unit. And then below that is a Trimble unit. And so they're all out there selling. All the manufacturers are very aggressive about selling this equipment. All right, SLAM. SLAM stands for Simultaneous Localization and Mapping. It's sort of the new kid on the block for reality capture, but boy, is it an incredible tool, both external and internal applications. You essentially walk with these devices and it both scans and photographs at the same time. And because of the algorithms that are included in the software, these units are able to calculate its position as the path changes. So it's sort of like, you know, starting with a set of data and then calculating where you are on the path as you scan along your destination. So it's interesting. So the, autonomous vehicles uses technology, and also robotic vacuum cleaners. How about that, huh? So this is a technology that will map your house, allowing the vacuum cleaner to miss devices and whatnot, map your house. Okay, so this is a scan we did with both the GeoSLAM handheld unit and a Faro Focus 350 scanner. And this is an ITI, the ITI local school. This is the process unit that they built and that they train people to go in through their school to ultimately work out there in process and refinery locations when it gets it started. All right, so it didn't start. There we go. All right, so this is initially collected by Handheld. Point 3D is a company that put this video together for us. So this is the Faro scanner point cloud that was colorized. It's got a surrealistic look to it. It's incredible what the software and process can do now. So you'll see some targets in here. See that target on that tank? These are targets that we observe at total stations, establishing control in the point cloud, where we then subsequently can plot 3D coordinates of everything we see in the point cloud. Point 3D is a vendor for both scanning units and the software that we work with. Great company. Scanning workflow. Well, you scan and process LiDAR. As simple as that one line sounds, it's actually fairly complicated, but I don't want to dwell too much on it. Nevertheless, once you have the LiDAR point clouds established in 3D space with state plane coordinates, you're going to pick out visible control and then the validation points and check it to make sure that the quality is there. That control was observed with GPS units. Then if you need to reprocess the LiDAR against the control to make those subsequent adjustments, and you check that against the validation, you can extract ground data from the point clouds, thereby creating digital elevation models or DEMs, and then you can process the rest of the data for modeling for tanks, roads, whatever the purpose, ultimate goal is. So the software that we use is along the bottom of this particular slide. Pix4D is a company based in the Netherlands, very well known for stitching together photographs for photomosaics, orthographic photography. Scene is a software product by Faro, allows us to manipulate data coming out of the Faro scanner. Bentley Inroads. Bentley is well-known software platform that DOTs across the country use for their work products. And Topodot is a certainty 3D software product that runs inside Bentley. Topodot is a very powerful tool for manipulating point cloud data to generate feature extraction from that data, like cross sections, etc. Very good product. GeoSLAM Connect is the software that GeoSLAM has to manipulate and process the LIDAR data coming from the handheld scanner. Recap Pro is an Autodesk product that can take point cloud data and create TINs, DEMs for use in Autodesk Civil 3D. And then there's Bloom Technologies, which is a relatively new software that allows companies to host numerous point clouds, put them together, and allow access on a web-hosted platform from people that want to make use of that data. Bloom Technologies allows you to use large point cloud, huge data files without having to transmit them across the internet. It's a pretty big deal. File sizes are huge in all of this. Transportation applications. So you have mobile LIDAR going down the highway. You would typically go down every travel lane or loop in the case of a 2-lane. And then on this particular diagram on the left is a protocol that was published by Florida Department of Transportation. They, with California, pretty much leaders of accepting and telling surveyors how to use LIDAR data, the quality of the LIDAR data. So in that particular diagram, you see X's and O's, which is control and validation points. And the validation points and control points that we use to set on the highway are shark's tooth. This is a common marking for highways. And then we're going to observe the tip of the shark's tooth with GPS. And the reason why we do that is that the shark's tooth is highly reflective, and the orientation of the shark's tooth is always clear when you see it in LIDAR data. Therefore, you know which tip of the triangle is the control point. All right, so, but you can also use existing pavement markings that are already out there. Rather than putting control down or your own markings down, you can observe the marks that are already there. In this particular case, these are arrows in a parking lot. And then we're going to observe the point of the arrow with GPS, and that's going to be our control, our validation point in the point cloud. One of the end products you can get, we talked about digital elevation models. This is an example of one on a roadway, open ditch. You have culverts in the red box, and that's the elevation model that is exported out of the data by software like, I didn't talk about Global Mapper, but there or any of the other software products. And that's a grid. This particular one is probably a 6-inch grid that has XYZ values. And from that, you can create cross sections and also contours. The color on the right is blue for low, red for high. You can assign whatever color spectrum you want on whatever value system that you want to use. All right, so here we have a client that has a salt mine, and there is a fresh air shaft going down to the salt mine from the top. Originally, it used to be about 8 feet, and through moisture seepage, it washed out to become a small cavern. And the salt mine owner operator wanted to grout the walls to protect the integrity of the shaft. And so we were asked to predict how much grout would be needed. And then the picture on the right shows the same washed out shaft, but it's pretty much create surfaces and then create a volume and then subtract a volume, and then take out the shaft, and you're going to come up with the grout. Doesn't actually work that easy, but it's pretty close to it. So that's a volume calculation example that we have. All right, so for this presentation a couple weeks ago, we took our scanners to New Orleans. We went to the St. Louis Cathedral set up in Jackson Square, and we scanned that building with the Faro 350. We focused 350. We then also went around the building with the handheld GeoSLAM, and then we went around the block a couple of times with the mobile scanner on the truck that you see in the foreground there. So from the scans, this particular face, the modeling was generated from the point cloud data taken by the Faro scanner. It was colorized by the pictures taken from the scanner. And so it's pretty amazing representation. The noise at the bottom were people that were there. It was Sunday about, I don't know, 11 o'clock in the morning. Fairly busy mass was going on. We should have gone there during the week, but we didn't want to take any production time away from our people. So anyway, the spire that has the cross, it's shown on the right. And so this is the kind of detail that you get. So here we see images of, this is one of the spires, and on the left is a colored mesh, and on the right is a wireframe TIN. TIN is triangulated irregular network. It's hard to say. And that's a very common technique to represent surfaces. In this particular case, it's the church that we used it for. All right, so from the GeoSLAM data that we took, both from the front all around the building, you can see on the bottom right, that's essentially a cross section of the structure at about 10-foot height above the floor. The top left is the facade of the front. We took sections. The interior section was below the front, and then the top right is the facade on one of the sides. It's the left side, I think the south side. So it's pretty cool. This so the scan that we did of all of this was done in under 3 hours, and the processing done by GeoSLAM draw application generated the details for the facade and the sections in about 12 minutes. So these are the kind of end product that you can use to create the facade in any. You can import this into AutoCAD, et cetera, et cetera. All right, so all three models, which is the Faro, the handheld, and the mobile LIDAR, were used to create this video. It's an interesting video. So on the right, you see Jackson Square. Left and right of the cathedral is the Cabildo Museum facades. And in the center of the square, you see General Jackson on a statue. Again, this was produced by a software product called Nubigon. Nubigon takes the data, and you essentially move the perspective of view and the direction of view along a path, and it creates the video that will follow along that path. We're about to turn right. I forget the name of the street, but this is Cafe du Monde. Levee is to the left. Now we're turning to face the cathedral. We're looking across Jackson Square. You're going to see these holes in the bottom. That's where the scanner stations were. I call it the cone of silence. You can see them momentarily here. So there's 1, 2. We had 5 different scan stations. There's the fountain in the park. There's the cathedral. You can see through the front facade and see all the exterior walls. So church was going on, and we walked in the ante room, held up the scanner above the people inside the sanctuary itself. We're going to provide these videos to both the church and the visitor bureau. It's pretty cool. I don't know if they'd be interested in them, but we want to do it. All right, so we're inside the cathedral right there, looking through it. Again, those black circles are scan stations. They were selling artwork in front of the cathedral. All right, so here we have an example of clash detection in the petrochemical market. This is a video demonstration of what it would take to position a new tank in the place of where that red one was taken out. And there's audio that goes along with this video, and I hope you can hear it.
Wilfred, I don't think we can hear the audio.
Okay, well, we'll just watch. All right, see, he's going to take that member out. He takes that out. He takes out another one. And this is to, obviously, if they take those out, they'll have to strengthen the structure. So now he has an open space inside the structure. So here's the new tank that they have to put back into the space. So there'll be a lifting crane in front of that. That's a diagram of the truck. So there's an animation he's created. He translates the vessel, lifts it up with a crane, brings it over to where the members were removed, again, translates it, and they jack it and move it into the space. So now they've successfully moved it in. But what he's done is he's made sure that that tank doesn't meet obstructions when they move it and translate it into the desired space. Sorry, y'all couldn't hear it. I didn't know that. So this is as-built data with a renovation and a new addition, and make sure it all works out just fine. So the last slide or series of slides talks about gateway to the meta universe. The meta universe is interesting. So Facebook's company parent, they actually changed the name to Meta. It's no secret they're going to take the social media from our real world into a meta world, surrealistic world. And so everything inside the meta universe is going to be a representation of somebody's imagination. You can be whoever you want to be, go anywhere you want to be. There'll be a whole ecosystem and economic system in the meta universe. They're going to have money. You're going to, anyway, it's amazing. If you dive into that, it's all kind of stuff about it. So Capturing Reality is a software company that scans out there in the real world, and you can use their product to stitch together scans, photography, and create. It's the reality capture of what was observed. Well, they're a strong company in the game video game market, and so they're so strong that Epic Games bought them. And this is the announcement. Epic Games plans to integrate Capturing Reality's powerful photogrammetry software into the Unreal Engine ecosystem, making it even easier for developers to upload images and create photorealistic 3D models in instance. Capturing Reality will continue support and development for partners across industries like gaming, visual effects, film, surveying, architecture, engineering, construction, and cultural heritage. Well, this announcement also had a video, and you're going to see what the software does and what Epic Games plans to do with it. For instance, on the screen on the right, all of these little white dots are representations of where an image was taken or a scan was taken in that 3D space. Let me get this going. Oh, you're not going to be able to hear this either. Uh-oh. I apologize. Can anybody hear this? Dina? We'll just watch.
Yeah, we can't hear it, but
No, we can't.
that's great.
Okay,
I can't.
let's just watch it. My apologies. I should have checked this out. But here you're seeing them scan, photograph real scenes that they're going to use it subsequently in video games. All those were the places where image and scans were taken. Castles that you might see in an Epic game. This is how they capture all that. So this is all real. Look, that's how they capture the reality of these medieval places. Epic Games is talking about how great they are with photo reality capture. So that was they captured a mummy and then recreated the mummy. So here we're slipping into some of the end uses in the game itself. It's where the money is. All right, so I'm gonna get out of this. All right, so when the client says you can do it cheaper, this is what you do. You got the wonderful product on the left, and then you got the cheaper version on the right. Why do I do this? I'm not sure. I just think it's a hilarious slide, and we're always exposed to price points. It's just a part of doing business. So about SJB Group, we're a 40+ man surveying firm. You already heard the introduction from Dina, and this is one of the things that we do. We scan, we photograph, we survey, we model, and then we take those results and design in that space. Any questions?
Thanks, Wilfred. Again, that was very, very interesting. I didn't know any of those things. But yeah, if anyone has any questions, feel free to put them in the chat, or you can just unmute yourself too and ask directly. I don't see any questions in the chat currently. So while y'all are thinking about a few questions, I had a few. Again, excuse my ignorance. I'm not a surveyor, but for the thing you're talking about that was handheld, like the SLAM, your niche, putting things together. For my very limited exposure to LIDAR, it was kind of what you were mentioning before, like the tripod ones where you scan a face, like the face of a building or a face of a dam, what you're saying. But these are handheld, and you don't have to, like, you can literally walk.
You literally walk. You literally walk. I wish I could. Yes. Let me go back in camera slide. Shoot, hang on. Let me go back to the picture and I'll show it to you. Here we go. Are y'all seeing this?
Yes.
So
Yeah.
this is the GeoSLAM. All right, so if you can see my cursor, this, so there's the scanner is turning inside this black glass, if you can call it that. And then at the same time, this thing will pivot about this axis. So it's kind of like this, the scanner is turning, and as you, it's like a flashlight, you're going to shine or point this in the direction of what you're trying to observe. And this one is the same exact principle. And this one has a wire that couples to the device. It's essentially a huge flash drive along with the software. This one Hover Map has that same tablet, so to speak, attached to its scanner. This one is a little easier to use in the hand, and then the tablet will be on a strap, and you'll carry it over your shoulder with the cable attached. So it tracks everything, what you're doing, where you go. I don't know if I answered your question. I hope I did.
No, yeah. I just want to know a little bit more. I guess you also mentioned that you all have one of those.
We do.
And so I guess what are some of the most common cases that you use, that one?
Well, we use it for mapping places that are relatively inaccessible from vehicles or drones. For instance, for the cathedral, we were able to set up the Pharaoh in front of the church, but along the alleyways and inside the church, we couldn't drive. Like, we couldn't drive on either alleyway or in the back. So instead, we just walked around the entire perimeter of the church, went inside the church, and it is able to keep the registration intact of the outside data to the inside data if you're doing it in a path and come back to the same point that you started in. You can't have an open-ended path. For every scan of the GeoSLAM, you start and stop in exactly the same place. And usually it's a solid level place that you put the scanner on, take it off, scan, and then bring it back and then stop the scan. So that's why GeoSLAM is so useful, is because it carries the registration of the point clouds along with it as it goes down its path. Did that make sense?
Yeah, it made perfect sense.
The GeoSLAM is really
sense.
cool, but you're not gonna, and they mount the GeoSLAM on drones and on vehicles, so you can accomplish mobile and aerial LIDAR with it. It doesn't have the range and accuracy. So if you look at range and accuracy, that spectrum, the very top is your terrestrial scanners. It's going to have better range and tighter control. The LIDAR scans are going to be very exact lines you're going to see in your processing. In the middle is your mobile LIDAR, like your Velodyne. And then at the bottom is going to be your GeoSLAM but it provides, it has much greater accessibility into the spaces that you want to scan. That's why GeoSLAM is really hot for scanning inside buildings that are going to get rebuilt, or you want to do as-built dimensioning. That's the purpose of that particular one. It's just a great tool.
No, that makes perfect sense. Again, if anyone has any questions, feel free to put them in the chat, or again, just unmute. I have another question. This is actually all very interesting to me. So you mentioned about, actually, I'm also very surprised. I actually streamed my wedding a few years ago, and how big streaming was, and there was all about games, people just watching people play games, and how big of a business that really was. But do you imagine, like, for example, for some of the traffic data, some of like Google and some of these companies are kind of going in and offering those services for that kind of data. Do you imagine some kind of gaming primarily gaming companies kind of also moving to this field at all, or there's not enough, revenue in this type of a thing, or
Well,
what are your
this
thoughts on that?
particular, well, I mean, what you said is already true. Capturing reality. This is a company that already is doing this for not only gaming, but they're doing the surveying, architecture, engineering, and construction. Wish I could go. I can't. I would take us to capturing reality. Anyway, I would go on that website, but this is not a hot link, evidently. Let me see if I can show you. I'm gonna have to redo my sharing. So let me share. How it is. Am I sharing? What are y'all seeing?
Are we still just see the presentation screen?
All right, new share. Here we go. Now what do you see?
All right, yeah, we see the website.
All right, so the industries that they support: architecture, reality capture, photorealistic environments created at staggering speed, photorealism and 3D visualization. So here is another example. If you can see this, this is, I think it's a church. Here is it. So they have all kind of industries that they're active in, surveying. Now we have not used this particular company. The reason why I went to this company, and because they were so impressive with reality capture and the different spaces that they're involved in. And then when the news hit that Epic Games bought them, that's a pretty amazing deal. So here is a application on the right. So this is a heat map that's probably colored by elevation. Again, red is high, blue is low. And I don't know what this is, probably a pile of something that somebody wants a volume of. And then here's an example of a building that they scanned. Let's see, I don't know if I can. So they did this with a drone of some kind. And this is probably a scanned image. This is not a picture. This is the kind of quality that they're going to get from a LIDAR scan colored from photography. Really is amazing. If you take enough pictures and scan data from enough positions of capture, it's an enormous amount of data. But then again, you put it together and you've got an amazingly complete, accurate, photorealistic representation of the scene that you're capturing. This is probably for gaming. I don't know what they use this for, but it's just an example they have on their website.
Oh, that's great.
So this is,
like you said, it's pretty much already there. Yeah, I didn't really realize that they're already doing kind of more of the actual surveying type of things too. So
they have drones now that will go underwater. You can fly them in. The propellers will then propel itself underwater, and you can capture. LIDAR doesn't work underwater, but the camera does. But you can get camera imagery underwater with a drone. I've seen that. It's just crazy what's all out there.
That's great. Again, is there any other questions? I guess I have one last one, and this will be the last one. A little bit more practical. Again, I'm not, not a surveyor. For the transportation applications that you talked about, you're traveling down a lane. You talked about control points. How often is it recommended to have those type of control points? Is it?
I will go back to the slide that talks about that. So Are y'all seeing the transportation applications?
Yeah. Mhm.
All right, so this diagram below, this is the protocols that Florida Department of Transportation generally requires. They want a spacing between control every 1,000 feet, and intermediate points are your so X's are your validation points. And so you're going to warp the data to the zeros, and then you'll check the value of the point cloud at these X's and compare them. Typically, we're looking somewhere, we're trying to get below 500s. We have done these sort of scans for DOTD. We've done maybe 10 to 20. I don't know how many we've done. It's quite a bit. And you can get accuracies repeatable to 500s with control, and it's checked by the validation. Did that help you?
Yeah, that's exactly my question. That sounds great.
We're
Well,
going to be doing some of this for Move BR for a
cool.
couple of highway projects that are in Move BR. Yes, sir.
Very good.
All right. Well, I'm going to bow out. Thank you all for listening, and I hope it was enjoyable. And I loved putting this together, and thank you for watching.
Yeah, thank you so much, Wilfred. I love the example of the square and the cathedral. That was actually quite amazing. But I'm going to wrap it up here and just share a few announcements from LPESA and also from LTAP. All right. I think I'm sharing my screen. Is that right, Dina?
Yes.
Okay. Actually, Dina, maybe you can mention this. I think you know a little bit more about the new room block.
Okay, so now, if you have not registered yet for the spring conference come April 20 to 21, please do so. Although we have already been fully booked for our first hotel block, Clarion Point is fully booked. We have a new set of room blocks available at the Hampton Inn. You can just use the code LPE to avail of the special rate, which is $149 per night. So, yep, we encourage you to join us in Sulphur.
Yeah, thanks, Dina.
You're welcome.
Yeah, we're definitely hope to see you all there. That's coming up very shortly. Actually, we're all getting excited for that. And then lastly, I'll talk a little bit about the upcoming LTAP trainings. And the one that we're starting actually next week is heavy equipment safety and maintenance for local agencies. We have a new instructor, Mr. Dwight Hutchinson, and a completely revised class. This is about general safety for operators and those that are just working around heavy equipment. Also integrates maintenance as well, so it has very good safety and maintenance tips and a nice overview of things to look for. We're actually going to have a piece of equipment at every location, and the instructor will kind of go through like a pre-trip inspection and also looking at some of the things you should be checking for maintenance at those. So we welcome you all to those. That's going to start next week. We'll have 8 locations around the state for that. And then after that, we'll have a series of roadway departure workshops. They will have actually 9 locations across the state. We'll be talking about how to and what strategies you can all use to prevent fatalities from run off the roads. Talk a little bit about some of the tools that we have here in Louisiana, some of the data that we have here in Louisiana. And also that will also include actually a field visit where you can do like a ball bank study, and also like a mini RSA, mini road, excuse me, a safety assessment. Again, just tools and strategies that local agencies can use to reduce roadway departures. And I don't think the registration is quite up for that, but I think it's almost up for that. We're still confirming, I think, 3 locations. But with that, I thank you so much for attending. Of course, thank you, Mr. Barry, for the presentation. Very interesting topic. And of course, if you have any questions, you can reach out to me or Dina. But with that, I think I'll let everyone go. Have a great weekend, everyone. Thank you for attending.
Thanks, everyone. That was good.